Welcome to adding and subtracting fractions today, children. First, we're going to take you through adding fractions, and then we're going to take you through subtracting fractions, step by step, so that when you're doing your homework, you can get to the right answer. So let's begin. We're going to begin with an adding fractions question. So we need to think about the steps to success. So I can notice straight away on my fraction that the denominators are different. We can see that they're different there. So what I'm going to think about is finding a common multiple of 4 and 9. So what I need to do, I'm going to write my m's of 4, which that is 4, 8, 12, 16, next one is 20, 24, 28, 32, 36, and 40. I'm only going to go to 10 lots. I could go less if I wanted. Then I'm going to do the same with my m's of 9. So we have 9, 18, 27, and 36. Wow, I'm going to stop because what I have noticed is that in both multiples times tables I have 36. Therefore, I know my denominators are both going to be, that's it, you guessed it, 36. But then what I need to work out, well, what did I multiply 4 by to get to 36? Well, I could count along here. 1, 2, 3, 4, 5, 6, 7, 8, 9 lots. Not 3 as it's been written there. Then that means I'm also going to multiply my 5 by 9. Well, 5 times 9 is 45. So I know my first fraction is going to be 45 plus, something. Well, what did I times my 9 here by to get to 36? Well, that is 4. So that means I'm also going to multiply my numerator by 4. 3 times 4 is 12. So therefore, my fraction is actually 45/36 plus 12/36. Then we have to think about which bits are we adding together. Well, the numerators do not get added together. That stays the same. So I can put that one in. We add our denominators. So I'm going to do that in a different colour for you. We're going to add these two together. Well, 45 plus 12 is going to be 57. So I have 57/36. But I'm not stopped there. What I'm going to think about now is, can I turn this back into a mixed number? Okay, so what I need to think about is how many 36 can I get into 57 without going over? That's 1. Okay, because I can do what I can do up here. I'll show you 57 subtract 36. Well, that leaves me with 21. So I'm going to have 21 left over. And the denominator stays the same. Then I need to think about if I'm going to simplify it, but this time I'm not going to simplify it. Well, I could simplify it because actually they're both divisible by 3. So I can have 1 whole. And if you notice 21 can be divided by 7, which equals, not 7, by 3, which equals 7. And 36 can also be divided by 3, which equals 12. So actually I'm going to have down here 7 twelfths. Let's try another one. So this time we have mixed numbers, which is helpful. And it can be the same issue. So the first job I'm going to do this time is I'm going to take my mixed numbers and I'm going to add those two together. I've got 3 wholes already. Then I can do what I did before. I'm going to find the common multiples. So m of 7, which is 7, 14, 21, 28, 35. I'm not going to go anymore just in case that is it. It's in there. So then m of 5. 5, 10, 15, 20, 25, 30, 35. I'm going to stop because if you notice, I have got a common one, which is 35. So what does that mean, children? That does mean, you're right, correct, that the denominator becomes 35. Okay, so then I need to work out what did I do to my denominators. Well, I times 5 by 7. I'm also going to times 4 by 7. So that's 28. So it's got something plus 28 35ths. Well, let's see. What did I do to the 7? I multiplied that by 5. So I'm also going to multiply the 3 by 5, which is 15. And then if we work out together, we can do 15, add 28. Well, if we add 10 to 28, that's 38. Plus 5 is 40. Well done. 3. 35ths. Oh, I've actually got 3 wholes and 43 35ths. Well, do you notice anything with this fraction? Yes, I've actually got another whole number in there. So if you look in here, I can do 43 subtract 35. Well, that's going to leave 8. Oh, that leaves me with 8. So I've actually got 4 wholes and 8 35ths. Let's have a look at the subtraction. So again, the denominators are different, which is fine. So what I'm going to do, I'm going to find Do it this side this time. The m of 3. 3. I'm only going to do the first 5. 3, 6, 9, 12. Oh well, actually, do I need to go on? Because if we notice, that's already a 12, which will be the same as our fraction here. I can make both denominators 12. Which means I can just keep this one the same. That can stay the same. Because I haven't changed it. For this one, I've times the 3 by something. 1, 2, 3, 4. To get to 12. So what have I got to do with the numerator, children? Right, I've got to times it by 4. Which is 20. We actually have 20 12s. Subtract 3 12s. You're probably thinking, what do we do next? Well, we subtract our numerators. 17 12s. Well, if you notice it again, this is another improper fraction. Another one. So we need to turn that into a proper fraction. So I can use my 12 times tables here. So I know the first one is going to be 12. So I've got 1 whole. If I do 17 subtract 12, that's going to leave me with 5. So I know I can't get any other lots of 12. So I've only got 1 whole and 5 12s remaining. Okay, let's have a look at the last one. So slightly different. We've got our mixed numbers. So the first job I'm going to do is I'm going to take my mixed numbers. I'm going to take 4, subtract 2 equals 2. Okay, done that bit. Then I'm going to look at my fractions. We notice different denominators. Well, I know that 12 is going to be the common multiple because 6 is in the 12 times table, 12 is in the 6 times tables. I can leave this fraction the same. What did I do to this? I multiplied it by 2. I'm going to multiply this by 2. Oh, that equals 2. So I'm actually going to do 9 12s subtract 2 12s. That equals 7 12s. And I'm going to add it